Bienvenidos, Ushamdi, and welcome CMIT 454, sections 6380 and 6382 for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the CCNA Security version 2.0 course from Cisco Networking Academy, and this evening's video tutorial is going to be a supplement on the zone-based policy firewall. And as you've made your way through Chapter 4, especially the latter half of Chapter 4, you've seen the increased importance that the material has placed on the zone-based policy firewall. Because again, this is really the replacement and enhancement of the context-based access control setup. So instead of just IP and spec commands, we now have sort of this C3PL language that we're incorporating, or the modular quality of service command line interface type syntax that's making this a little bit more difficult. And so that's why I want to go ahead and spend a little additional time sort of working our way through here. All right, so let's go ahead and jump on the command line and get into our zone-based policy firewall configuration. Again, we're going to be using real Cisco 2911 routers, all running 15.5 or later code. So this will give you a good idea as to what this would look like if you were to actually configure it yourself. Now, we're going to be dealing, and let's go to the blackboard real quickly here. We're going to be dealing with the following configuration. And as you can see, we've still got some things left over here, so let's clear the slate there. And we're going to be set up with that same configuration that we've worked with the whole time here. We're going to have router 1, router 2, and then router 3. And the way that we're going to look at this is that here is where we're setting up our border, right? Our firewall is going to be set up there. So over here to the right-hand side, this is going to be considered the inside zone, right? And this is going to be considered the outside zone. And so that is how we're going to set things up. And again, similar to the exercise that we did in Packet Tracer, but now we're going to address that question as to why can router 1 ping the transit interface on router 2? Why is that possible? So we're going to dig into that self zone here as well. So again, this is what we're working with. So all of our zone-based policy firewall commands will be set up right here. And let me thin this line out a little bit. Going to be set up right there. Okay, so let's go ahead and jump onto the command line. And let's test connectivity. So here we are on router 1. So I'm in the outside, right? I'm out on the internet. Let's go from user exec to privilege exec with the enable command. And then I'm going to say ping. Now, can I ping through router 2 to the router 3333? And actually, that's not going to work. I need to source that from the loopback 0 address. So as you can see, we have connectivity. Now, can I ping the transit interface, which is 10.1.2.2. Now, this is on router 2. So as you can see, I can actually ping the interface of router 2. Now, when you stop to think about this, is this something that you want to allow? Do you want to allow hosts on the internet the ability to do reconnaissance and ping the transit interface of your border router? And the answer to that is no. And so let's go ahead. We're going to work our way through the zone-based policy. Now, remember, with CBAC, context-based access control, we could not do this unless we accommodated for this in that ACL. Because remember, we had that deny IP any ACL placed on that outside interface. And we made an exception for OSPF. But unless you make an exception, you're not going to be able to ping that transit interface. But with zone-based policy firewall, it's different. The interfaces that are on the router itself, and this is for all of the interfaces on the router, they fall under what's called the self zone. In other words, the router itself. And so we're going to see how we can go ahead and set up an outside to self policy to protect ourselves from that kind of traffic while still allowing the OSPF traffic, which we need to maintain that adjacency. We're going to allow that traffic to come through. So let's dive in here. Let's get onto router 2, which is our border router. And we'll go from user exec with the enable command to privilege exec, and we're going to go right into global config. And we know what we're looking at here, right? So we want to create a zone security, and we're going to say inside underscore zone. We're going to give it a nice distinctive name. Now, different than packet tracer, right? Really the only thing I can do here is put a description. So it's kind of self-evident and obvious what this means. So maybe you put something in here like a quick comment. Hey, TP bond fee and the CCR that I used to create this was 8675309, and the date that I did this 01/11/2018, right? So again, I can't stress this enough. Documentation is probably the most overlooked aspect of network engineering, and it can really save you as well as people that are following you a lot of heartache if you can document things in a granular way. So then we know that we're also going to need zone security outside underscore zone. And these are arbitrary names. I could name these things anything that I want. What you don't want to do is you wouldn't want to say zone A, zone B, zone C, because those are absolutely meaningless zone names. Those, you know, that would leave a lot to the imagination. All right. So we're not going to do an ACL for the inside to outside zone pairing. I want to do something different than we did in the packet tracer, because again, I don't want this to just be a copycat of the packet tracer. So once we create the zones, what is the next step? So I say zone security inside zone, zone security outside zone. Now what do we need to do? Exactly. So step 1 is define which interfaces are going to be, you know, part of what zone, right? And what zone naming scheme we're going to come up with. Step 2 is create the zone. Step 3 is we're going to create the class maps. Now remember, this is very important that if I say class map and I say inside underscore C map, am I creating an inspection class map that I'm going to be able to match protocols with? And the answer is no. Remember, we're using the same C3PL and modular quality of service CLI command syntax that's used with quality of service, with QoS. And so we need to make sure, and this is probably one of the most common mistakes I see with learners, is you want to make sure you remember to say type inspect. Very, very important. And then we get down to our logicals. And what I mean by that is now we've got a choice here with match any and match all. And remember, when I say match all, it means that it's going to check to see, does everything I list in the match criteria, is it satisfied? So if I said match protocol TCP, and how about a match protocol UDP? And if I used match all for this, what traffic would match that? Yeah, none really, right? Because no traffic is simultaneously TCP and UDP at the same time. So this is going to fail. So you got to be very, very careful. All right, so if we want a logical or, if we're trying to say, yeah, I'm interested in TCP traffic or UDP traffic or ICMP traffic or HTTP traffic or DNS traffic, I would say match any. And again, this is probably one of the trickiest things when setting things up. Now, let's do this. What if I don't put anything? Because again, take a look. I can put the name right now. So what if I said inside underscore CMAP? Do show run include class dash map? What is the default? Yeah, the default showed up right there. So again, it's very critical, very tricky, a lot of little little landmines that are out there that can catch you here. So remember, make sure that it's a type inspect class map, and make sure that you specify if you're not doing match all. And it's not a bad idea to always put in there what you're going to be using to make sure you're clear on that. Even though it shows up here, you want to make sure you put it in there. And inside CMAP. So obviously that's not what we want to do. So let's pull this back, and we're going to go ahead and say no class map type inspect inside CMAP. And we don't even have to put the match all. It thinks that that's the default. So we'll pull that command back, and we'll save ourselves some typing. So type inspect, we're going to say match any, right? So I'm going to give a couple of protocols here that we're going to match, and I'm going to leave a couple out. So from here, right, we could put a description as well. I'm going to leave the description out. We've already seen that. What we're interested in is the match protocol. Now remember, in the packet tracer activity, what did we do? We said match access group, and then we put an ACL in there. And that's fine. You can do it that way as well. In fact, you can use both match protocol and match access group in the same class map. So if I wanted to match TCP, but only from a select group of hosts, I could do that as well. And so let's go ahead and set this up. So we're going to say match protocol, and I'm just going to match generic TCP. I'm going to say match protocol. I'm going to match generic. And again, if you do a question mark, you can see all these great things that you can choose from. Let's say DNS. And how about match protocol HTTP? Right? And I think we can do HTTPS as well. So there we go. So now what does it look like? So do show run section. I'm going to pipe it to section class map. And this is different because this is going to show me just the class map section. So what are we looking at here? Well, we're doing generic TCP. And if you're looking at this saying, well, why did you put that in there? Because you said HTTP later. Well, remember, generic TCP is not just HTTP. It's FTP. It's Telnet. It's SSH. It's all the other SMTP, all the other TCP-based protocols are going to match that generic TCP. And then I said HTTP and HTTPS just for a little more to spice things up. And then I said match protocol DNS, because you'll notice I don't have match protocol UDP here because I'm not interested in all UDP applications. I'm interested in the DNS application. So that's our class map. So we have created the zones. We have defined the traffic that we want to match. Remember, the class map is all about matching the traffic, identifying the traffic that we are then going to use what to dictate what happens to that traffic. Exactly. The policy map. So once we've got the class map, now we need to come back with policy map. Now, what if I were to say policy map and say inside underscore PMAP? What kind of a policy map am I creating? Exactly, I'm creating one for QoS. Remember, with zone-based policy firewalls, we are inspecting, right? We're interested in inspecting. So the class maps and the policy maps will be of type inspect. And so here's where I can put a word in, I can put a name in inside underscore PMAP, right, for inside underscore policy map, and hit enter. So now it's here where, again, we could put a description, not a bad idea, and I can say class, and again, be careful, because you see right here it says, oh, class map name. So I could say inside underscore CMAP. That's what I'm looking for, and I'll hit enter. But is that what we wanted? No, right? Remember, no class inside underscore CMAP. Remember, we want class type inspect inside underscore CMAP. And now here we are. What do we want to do with that traffic? Do we want to drop it, which would basically be like a deny statement in an ACL? Do we want to pass it, which is like a permit statement in an ACL? We can apply a service policy, right? And so this is a little additional information here, and that's that deep packet inspection engine. So if I were to say service policy and do a question mark, we could do HTTP, right, for a deeper packet inspection. So we can do it with H323 traffic, HTTP, POP3, SMTP, right? Here's where we can do that URL filtering. So that's where we would add in an additional service policy. But we're interested in inspecting this traffic right now. So I say inspect, right? So now we've got the zones created, the class map is created, we've got the policy map created. What's the next step? Exactly. Now we need to go ahead and create our pairing, right? Pair the zones up, and we're going to do the source and the destination here. So I'm going to say zone pair security, and then we're going to give it a name. And so we're going to call this inside to outside, right? And here's where I say, what's the source zone? Well, it's inside. And actually, let me back up here. If I do a question mark, it'll give me the names. So, and this is probably iOS dependent. I don't believe back with later 12 code, I don't think it did this. But with 15 code and the 15.5 and on, this is definitely the default. And it's nice. It saves you from doing a lot of typing. And you can see it actually puts the comment in there so that we can, again, get some additional information and see, okay, oh, right, yeah, we want the inside zone. That was the one that we did with that CCR. So I'm going to say source inside zone, destination is going to be the outside zone, and that's it. So now we get here, and this is where we apply the service policy of what type. Remember that, inspect, and this is going to point back to the policy map. So again, we pair the zones up here, inside being the source, outside being the destination, and then we refer back to the policy map that says this is what I want you to do to the traffic that I'm matching, and it refers back to the class map. So we go back to the class map to see I'm doing this, but what traffic am I doing it on? And it's TCP, generic TCP, HTTP, HTTPS, DNS, right? And so that's how we set ourselves up, right? You can see it pause there. There's a little break there for a second, right? Because now it's setting that mapping up between the inside zone and the outside zone. So we created the zones. We created the class map where we match the traffic we're interested in inspecting. We created the policy map where we say for the traffic we're matching, this is the action I want to take. Do I want to drop it? Do I want to inspect it? Do I want to just let it pass and not inspect it, right? And we chose inspect because we want to see what happens when we're inspecting. Then we created the zone pairing. Now that that's done, the only step left is now to apply the service policy. I apologize. The only step left now is to go to the interfaces and add the interfaces as members of the zones that we created, either the inside or the outside. And before we do that, we'll go ahead and do the first piece of that actually right now. So let me jump into show IP interface brief. So I'm going to do the inside interface first, and that is the one facing router 3, int gigabit Ethernet 01, right? And so how do we do this? We say zone, what is it, member? Yeah, zone member security. And what zone is this interface a member of? And I think it's the same thing. I think it'll show us. Yeah, there's your choices, right? So inside zone, and that's it. So I say zone member, security, inside zone, and I hit enter. So now let's pause here because the chapter placed a lot of emphasis on the different variations that you can have, where if you've got an interface that has no zone membership, trying to communicate with an interface that is a zone member, or two interfaces but they're in different zones, or two interfaces in the same zone. What does that look like? So we're inspecting traffic on the inside. So you would expect, and we tested connectivity, you would expect that I could come over here to router 3, and I should be able to say ping 1.1.1.1 and source that from my loopback 0 interface. And we would expect that this would work because I'm inspecting the traffic, right? So why is it not allowing the traffic to come back in? And that's because right now, this is what our configuration looks like. And let's change our colors here. Yellow kind of pops off the screen a little bit better. Router 1, router 2, router 3, right? So the way we're set up now is we've got a policy here, or I should say, I don't want to say policy. We've got a zone membership here on this interface, but is there a zone membership here? No, there's no zone membership, right? And so by default, right, an interface that is not in a zone cannot communicate with an interface that is in a zone. And so that's very important because that's the problem here is the ping traffic's being inspected, right? But we're going to an interface that's not in a zone. In fact, even if the traffic were to come back, we're going to an interface that is not a member of an active zone, and the traffic is coming through an interface that is in a zone. This is not going to work, right? So let me go ahead and pull up this image. And every course, there are a couple of images that are literally worth their weight in gold. And this is one of those images. So transit traffic, and we're going to come back to this to talk about the self zone later. So with transit traffic, which is the traffic we're talking about, so zone interface, a member of a zone. We've got no and no. If they're both not members of a zone, then that's fine. Remember, if they're not participating in the zone-based firewall, then traffic is going to behave as it normally does. And the router is going to do what it normally does. It's going to route the traffic. And you would have to, if you wanted to do any filtering, you would have to use some sort of an ACL. Or, even more interesting, on the interface that's not a member of a zone, working with another interface that's not a member with a zone, you can use CBAC. So CBAC and zone-based policy firewall can operate together as long as they're not configured on the same interfaces. So this is a use case where maybe, yeah, you've got zone-based policy firewall running for part of the router, but you know what? The other part, I just want to do CBAC because we don't need zone-based policy firewall. So that's a possibility, right? You can mix and match. But just remember, if either interface, and these two right here describe this perfectly, right? If one interface is a member and the other interface is not, right? So if the source is a member, the destination's not, or if the source is not a member and the destination is participating in zone-based policy firewall, drop, right? So that's the way it's going to go. So it's all or nothing with zone-based policy firewall. Either all of the interfaces are participating, right? Or they're not. Now, you can see here what's going to happen when it says, it says private, and then it says private, public, and then it says private, public, but it's talking about a zone pairing existing. So right now, our source interface, our private interface, and where's that at? It's going to be the private interface, and okay, destination we haven't put in there yet, so we'll deal with that when we get to it. So if a private interface, like our inside interface, is the source, and another private interface is the destination, in other words, this is intra-zone communication, right? So what is going to happen here? So in other words, if I took another interface on the router and made it a member of the inside zone, could it communicate with gig 01, who's already in the inside zone? Absolutely. The traffic, not only is it allowed, it's not being inspected. It's simply the equivalent of the access list saying permit, right? So the same zones, intra-zone, absolutely. Now, What if we have an interface that's in the private zone, right? The inside zone, and the outside zone's configured, right? So we've put both interfaces in the zone, but we didn't do a zone pairing. And this is why the zone pairing is critical. It's going to drop that traffic. Now we get down to this iteration. So yes, the inside interface is a member of a zone. The outside interface is also the member of a zone, and the zone pairing exists. And this is where we're going to be here shortly. And then it says policy exists. So if there's no policy, it's just going to pass the traffic. Now, if the inside interface is in the zone and the outside interface is in its zone, and the zone pairing is configured, and we've created the policy map and the policy is applied, that is where we're going to end up in our scenario. It's going to be inspecting the traffic. And so again, the two images that were in the chapter, absolutely phenomenal, right? This makes it really, really easy to look at and understand. Now, where are we at right now? So we're where? We're here, where this is us right here, where yes, the inside zone's a member of a zone, but the outside zone is not. And you can see, it doesn't matter if there's a zone pairing, and it doesn't matter if there's policy, because this guy is not in his zone, right? This interface is not in his zone. So let's resolve that issue. Let's get gig02 into his interface. Oh, and you know what? Real quickly, so I was doing ping. Are we inspecting ICMP? No, we're not. So what would be a better test if I was to say SSH-L admin to the 1111, right? Is that going to work? And the answer is still no, because again, we've got one of the interfaces that's in a zone, the inside interface, and then we have the outside interface through which we need to go that is not in a zone. That traffic is going to be dropped, right? Traffic is going to be dropped. So I'll let that time out. We'll come over here to router 2. We'll get into interface gig 02, and now we're going to go ahead. We're going to complete our configuration right now by saying zone member security outside underscore zone. Now, when I hit enter here, what I could say is, what is it? Show zone pair. I think it's show zone pair security. Yeah, so show zone pair security is going to show us the zoning configuration that we have right now. So we have a zone pairing that's set. It's called inside to outside. So the source zone is the inside zone, and the destination zone is the outside zone. And what policy, and remember, that's that next to last option is what this is talking about. The policy, see where it says no right here, right? We have a policy applied. We have a policy applied. So now when I go back over here to router 3 and I say show IP route OSPF, do I see the routing information for the 1111? Absolutely. Can I ping 1111 sourcing it from my loopback address? Remember, this worked earlier. Does it work now? So why am I not able to ping? Exactly. We're not inspecting ICMP. So the premise of this activity is just like the CBAC activity that we did. This is our company. We are xyz.com, right? We're connecting into whoever it may be, Verizon, AT&T, Comcast, Cox Internet Cable. Doesn't matter. Some provider. And this is irrespective of whether we're doing BGP or whatever the routing protocol. We could be using static routes. We want to protect this router at the remote site. So we do zone-based policy firewall to ensure that only return traffic that has initially been inspected is allowed back in. And what we mean by that is, there's where I'm doing my inside interface, and that's where the inspection of the HTTP and HTTPS and DNS and TCP, generic TCP, is taking place. So from router 3, if I SSH, when it hits this interface, that's generic, it's going to be matched by the generic TCP. Router 2 is going to create a state table entry for that. We're going to go out the outside interface over to router 1 with our SYN, a SYN ACK, and then all other traffic will be coming back, right? All this SSH traffic will be coming back to this outside interface, who is going to say, hey, you know what? I have a connection table entry for that. That traffic is allowed to come back through. So the reason that the ping is not working is because we're not inspecting the ping. And again, we're not inspecting the ping because we're going to do something with that a little bit later on here. So let's get back to the command line and let's get on router 1. And let's see. So router 1, remember, router 1 was able to ping 3.3.3.3 when we sourced it from the loopback 0 address. But this is what we want. We don't want people, bad actors on the internet, to be able to reach our internal hosts, right? That's a recipe for disaster. So this was where we left off in the packet tracer activity. Can I ping the transit interface 10.1.2.2? Right? And so this was what happened in that packet tracer activity. And I left you with that question. How come I can't ping the 3333, but I can ping the interface to which router 1's directly connected over on router 2? And the difference is this, is that this is transit traffic. It's going through, I'll just say trans, it's going through the router over to router 3. It's transiting router 2. Whereas this traffic is destined to router 2. Whoops, SELF. And that is our self zone, right? That's the self zone. So that is why this works. And we're going to address this in just a second because there's an additional step we need to take to secure the control plane of our router. And this is where we will do an ACL up, and then we're going to do an outside to self zone configuration. So let's clear our screen. And now we've confirmed, hey, our zone-based policy firewall is doing exactly what it's supposed to be doing. Users on the inside LAN, they're not allowed to ping out, right? There's no reason. They're just supposed to be surfing the web and using TCP-based applications. And everybody on the internet is not able to originate or initiate a connection through router 2, not to router 2, but through router 2. So we've got our zone-based policy firewall. It's doing exactly what we want it to do. And you'll notice the other difference here. Did OSPF crash when I put the outside interface into the zone? No, it didn't. When we did the reflexive ACLs and when we did CBAC, remember that happened because there was an ACL we put on that outside interface. And so that broke the routing protocol, and we had to take that into consideration and accommodate the fact that we had a routing protocol running. So here, zone-based policy firewall does not do that because of the self zone. And so what can we say about the self zone? Is it blocking all traffic by default, or is the self zone wide open, allowing all traffic by default? And yes, it's the latter, right? And we just saw that right here. So we want to protect ourselves against that, and we'll do that in just a second. So now let's confirm from router 3, when I say SSH -L admin over to the 1111, is this going to work? Absolutely. So we're going to go out and give me a second here. Maybe there's something I might not have set up with. And we might have to let this time out, actually. So I may not have set the source interface up with SSH. So give me a second. And let's see, show TCP brief. Do we see it over here? We don't. Whoops. And we'll let that connection time out. Let me do a show run, include SSH. And that is exactly the problem. I apologize. I left out the IPSSH source interface loopback 0 configuration setting. And now let's redo that. And let's see. There we go. That is what we're looking for. Okay, so we've proven now conclusively. Let's get the password in there real quick. Now you can see I'm over here on router 1. So now I'm going to say show, and how about a, is it a tech support? There's a limited tech support command that we can do, or show, what is it? Show tech unprivileged. That's what it is. Show tech unprivileged, which again is going to sit here, and it should have continued on, because I don't think we have the enable password set. So let me do this. We'll say Control U, and to make this easy enough, let me go ahead and get into global config and just say enable password ABC123. Not recommended in your production environment. So now when I say enable here, I simply say ABC123, and I can do show tech support, which is going to run forever, right? And so then we'll let this go on a tear. And the reason I'm doing that is because I want to make sure that the TCP, the SSH session remains intact. So what we can say now is we can say show zone, or actually show policy map. Show policy map, and let's get this sorted out here. Show policy map session, and show policy map. We're gonna have to do, I forgot to type inspect. Show policy map, type inspect, and then we'll just let this go. So you can see that's our setup there, and then we want more information. We want to see the inside to outside. There's what we're looking for. All right, so here is the configuration that we have, and this is showing us the statistics, and we're going to go a little further down here and we'll see the connection that exists. So match protocol TCP, right? We can see that the inside class map, which is match any, is actually matching traffic. We're not matching any DNS. We're not matching any HTTP or HTTPS, and that's fine, right? Those were just kind of in there as filler. We were more interested in the TCP for the SSH, and then you can clearly see here that we've got some TCP packets that are being fast switched. Let me clear that, and let's move our way down a little bit and get to, and I make sure that that is still up. Yeah, so it's still up, so we should see, and I can never remember, show, is it zone pair? Security, I don't think there's anything after that. Source, yeah, so we can do inside zone and then destination, outside zone. I'm not sure if this is going to give me what I'm looking for, and it's not. It's got to be in that policy map setup, and type inspect, and the policy map name, we don't want that. Zone pair, yeah, I could have swore that there was another name, so I'm going to say inside underscore pmap. No, and that's not it. So we should be seeing the session. We're clearly seeing the statistics. And did I go right by it? No, I didn't go by it. It'll come to me in a second here, but I'm having a problem remembering the command that will actually show us that the session has been enabled. So here's what we're going to do now. So now we're going to address that self-zone issue that we're having, right? Or I shouldn't say the self-zone issue. We're going to protect ourselves and protect that self-zone by making sure that it's protected. So how do we do that? Well, we do the exact same thing that we've been doing here with zone-based policy firewall. So here's how this is going to work. So the first thing I'm going to do is we're going to go ahead and we're going to say how we're going to do it. Well, so here's what we'll do. We'll go ahead and say that OSPF is allowed, but that everything else is not coming to the self zone. So in other words, ping would then get blocked coming to the self zone. And here's how that'll work. So here I am on router 1. Remember when I said ping 10.1.2.2? This is the transit interface of router 2. And you can see that that works. So I'm going to say repeat, and we're going to put in here an artificially large number. That was too large. Still too large. Let me come back a couple. There we go. So now that should last us while we do this zone-based policy configuration. So the first thing I'm going to do is let's use an access list here for this, right? Because that's going to be probably the easiest thing to do. So we're going to say IP access list extended, and I'm going to say, call it OSPF, because that's what we're doing here is we're allowing OSPF. So I'm going to say permit OSPF any. And then I'm going to say deny IP any, and we'll log it. And actually, I'm not certain. I may have to log it. Yeah, let me do this. Because we can log it through deny IP any. So we'll say deny IP any, and that would be at the end anyway. It's the log command. I don't know if the log option is allowed here. I'd have to double check on that. So the ACL, we're going to allow OSPF, so we maintain our neighbor adjacency, right? And then we're going to deny everything else. Now, remember, the self zone applies to all traffic destined to the router, not transiting the router. So if you're looking at this right now and thinking, well, Travis, as soon as you apply that, router 3 is no longer going to be able to SSH to router 1. Now, that's not true. Remember, that traffic is going through router 2. It is transiting router 2. It is not destined to router 2. In fact, if I come over here, and that is not, is that the right router? No, that's not the right router. Sorry about that. Yeah, so we're still, let me see if I can kill this. Is there a way out of this? No, the tech support's going to continue to run, so we'll let it do its thing. So we've got the ACL configured. So now what we need to do is we need to do what we did in the packet tracer activity. We've already done this, right? It's very straightforward stuff. So class map, type, inspect, inspect, very important. And I'm going to call this, what are we going to call this? So we said inside for the other one. I'm going to call this outside. Or should we call it self? I'll call it self. So we'll say class map, type, inspect, self. And we'll leave it match any because there's not going to be multiple things here, right? So I could say match all. Well, I guess we'll leave it as match all. Yeah, we'll leave it as match all because there's only going to be one thing here, and that is going to be we're going to be matching the access group that we called, which is our ACL. We named it OSPF. So now we've got the outside zones, or the self zone is already in existence. Match access group. I have to get the name in there, OSPF. So we've already got the outside zone created. Now we're just creating, and the self zone's already created. Now we're just creating something we're going to be applying to the self zone. But we've got to pair those zones up. But before we can do that, now that we have the class map, what traffic am I interested in matching? Now, what am I going to do with that traffic that I have matched, right? And so actually, yeah, we've got the policy map next. So we'll do the policy map. So I'm going to say policy map, what type? Yep, we got to make it type inspect. And we're just simply going to call this, what do I call it? Self. And I didn't say self CMAP, so I'll say self and get that right this time. Underscore, we'll say PMAP, right? Now, underneath the policy map, we say class map or class type inspect, and this is where we refer to what? We put the class map name in here, which we simply said was self. Now, class default, remember, that's sort of the catch-all at the end, sort of your deny IP any at the end. So I say class type inspect self, and then we get into the bottom configuration. What do I want to do? Do I want to inspect it? Do I want to let it pass? I certainly don't want to drop this traffic because it's needed to keep that OSPF adjacency up. So let's just go ahead and let's inspect it. All right. So now that that's done, I've got the class map created. We've identified the traffic we want to match. We've identified what we're going to do with the traffic in the policy map. So now let's do our zone pairing. So I'm going to say zone pair security, and we've got inside to outside. This is outside to self, right? So here's how we'd add in an additional zone pairing. So I say zone pair security outside to self. The source is going to be coming from the outside, And the destination is going to be outside underscore zone. Sorry about that. And the destination, if I do a question mark here, you can see we've got the two we created, but then we have self. I'm going to hit enter. Now we have to tell it, for this zone pairing, what policy do I want to apply? And again, that goes back to this image here, where we saw that if there's no policy, it's just going to pass the traffic. And now we're talking about the self zone, right? So here we go, the source interface, member of a zone, and the source is the outside. So yes, it is a member of a zone. It's the outside zone, right? So O-U-T. I'll just put O, outside, outside, outside. Now, destination member, is it going to be a member? It is of the self zone pairing. Well, right now, no. And again, the policy, does it exist? Yes, it exists. We just haven't applied anything yet. We're going to do that here in 2 seconds. And then what's going to happen? We'd allow it to pass. Now, again, if it's the outside zone and the self zone and the zone pairing exists like ours does right now, even with no policy, the traffic is just going to be allowed to pass. But if we've got the outside zone and the self zone, which are both members of their respective zones, and the self zone is, by default, the zone pair exists, yes, we're going to apply the policy here in about 2 seconds. And the result is we're going to be inspecting that traffic, and that is what we selected. So let's go ahead and do that right now because we've got the pairing set up. And now we want to go ahead with our service policy command, right? Service policy, what type of service policy? Always inspect. And what was that policy map name? And I'm pretty sure I said self underscore PMAP. And let me scroll up just a little bit. Yes, self underscore PMAP. All right. So this is going to bring us into the scenario where we now have that zone pairing set up. So now let's come over here to router 12. Now, isn't this interesting? Or I should say router 1, right? So take a look at what happened to router 1. The traffic was passing the whole time, but as soon as I put that service policy statement in, right? Oops, sorry, wrong control tab there. As soon as the service policy type inspect self PMAP got dropped in there, right? What happened? Yeah, the service policy went into effect, and the service policy says, I'm looking at the class map that's looking at the access list that's going to dictate what traffic I'm going to inspect. And so if it's OSPF, hey, come on in. You'll notice the OSPF adjacencies haven't dropped yet. And if I was to say do show IP OSPF neighbor, right? Hey, everything looks great, right? Take a look at that. Yeah, our dead timer, we're counting down, but we're not going below 30. Perfect, because the ACL had had 2 access control entries. And what it said was allow, permit, OSPF, any. And so it's doing that. But then we have that deny IP any at the end. So all other traffic going from the outside now, and this is key, right? Let me make sure I stress this because this is typically where confusion comes in. What we're saying is all traffic right now that is coming from the outside going to an IP address on the router. The only traffic allowed to go to a transit interface is OSPF. And that's all we need. And take a look at what we've just done. We leveraged zone-based policy firewall and made it so that we can now protect router 2. So let's see something though. Let's check and see if, and let's check and see. Okay, so the show tech support is done, thank goodness. So I'm over on router, you can see my session with router, I'm still logged into router 1 here, and this is from router 3, so let's exit out here, right? So I've exited out of router 1, or I'm sorry, and now I'm back onto router 3. So what if I wanted to say show IP route OSPF, right? Do I have the loopback address of router 2. I do. What if I were to say SSH minus L admin and go to the 2.2.2.2? And first let me see. I don't know if I ever generated, what would it be? Line VTY 0 to 15, login local. Because now we're going to talk about managing the router, right? What if I wanted to SSH to the router to manage it? So login local, and then I'm probably going to have to say crypto key generate RSA modulus 1024 IPSSH version 2, and we should be good to go. Let's see here. So from router 3, so connection closed by foreign host. Do I have? It wouldn't have run with the domain name. Invalid client IP domain dash name, and we'll say CCNA security.com. I'm just trying to make sure that I did this invalid. So that error there, invalid client info or protocol info. Do show run, and let's include SSH. I'm not going to get us bogged down on this too much. Oh, I forgot. Line VTY 0 to 15. Transport input SSH. So by default, the VTY lines are transport input none. There we go. So now you're probably asking yourself, well, wait a second, how come you can get to the router from router 3, but not from router 1? Why is that working? If I said Cisco, you can see CISCO. At least I thought that was the password, and maybe that's not the password. And let me see, does the username exist? We'll say username, admin, password, Cisco. And now let's give it a try. So we'll say CISCO, and there we go. So we're on router 2. But what if I come over to router 1? And let's kill the ping, right? Because that's no longer working. And I say SSH minus L admin, and I'll go to the 2.2.2.2. Because I have a route to get there, but I can't. Why is that? I can do it from 3, but not from 1. And again, remember, this is where the zone pairing comes into play. Because the outside zone, it's outside to self. That is what we defined, right? Did I do a definition for inside to self? No. So in other words, the self zone, when traffic is coming through here, right, we can hit that transit interface. That is still going to work. In fact, let's pop out and go to router 3. And actually we did the SSH, but to show, can I get to SSH-L admin 10.2.3.2? And there we go. And we're in router 2. All right. Well, this is going to wrap up our coverage on zone-based policy firewall. So let's do a quick review about some of the things that we discussed, because there was quite a bit on the table here in this supplement. And this slide right here, again, this is the money slide right here, right? It gives you the breakdown of how zone-based policy firewall, how the interfaces are going to behave based upon whether they're members of zones, whether they're not members of zones, what if they're in the same zone, right? And so as a brief review, intra-zone, 2 interfaces that are members of the same zone, traffic is allowed to pass. 2 interfaces that aren't members of any zone, yeah, traffic is allowed to pass, right? The self zone, by default, everything is allowed to go to the self zone, right? We've got to get in there, like you saw, we have to get in there and protect ourselves by using that modular policy framework to create a class map, and then a policy map, and then a zone pairing for outside to self to allow the routing protocol that we want, right? If that's the case, and then to just block everything else. And let's say that maybe, so what if you've got some, VPN activity coming through, right? Trying to get to something behind the router. Well, then you'd need to account for that in that ACL, right? And it was the same kind of accounting and accommodation that we made with reflexive ACLs and that we did with the context-based access control, right? So again, that self zone was very, very important. All right. And then we actually saw some good examples as to how we would be able to, if you don't want people pinging, right? Just don't inspect the ping. And we looked at how we would match protocols as opposed to the access groups. In other words, those ACLs. So again, a little more difficult from a configuration perspective, but it's definitely from a scalability perspective. If you're talking about adding multiple interfaces in, maybe throwing a conference room, a DMZ, maybe a partner zone, now you want to start, that's definitely a zone-based policy firewall sweet spot right there when compared to context-based access control. All right, well guys, this wraps up the firewall conversation. Our next video is going to be on Chapter 5's Packet Tracer, where we're going to be taking a look at another, again, phenomenal feature that is part of the security license that you have. If you have a security license on your ISR G2, you've got iOS IPS, intrusion prevention system. So you've got firewalling, you've got stateful firewalling, and you've got intrusion prevention, all there with your security license. All right, thanks so much for watching, and I'll talk with you guys soon.